Hey everyone, so before we start delving into problems and all that messy stuff, first we have to know the derivatives of the trigonometric functions. So to help learn the formulas, I have a little trick for you guys. However, for this trick, you will still have to memorize the derivatives of sine, secant, and tangent, aka the functions that don't start with co. Looking at the table I've made, you'll notice I've already written out all of the formulas for you guys. In addition, I've paired up certain functions next to each other, and I've color-coded everything so then you can tell which functions are opposites of each other. What I mean by opposites is that for each function that starts with a co is going to be the opposite of whatever function it's adjacent to or color-coded to. For example, cosine will be the opposite of sine since they're both orange and are next to each other. In addition, their derivatives will be opposites. It's really important that you remember what's the opposite of each function, since you'll need to know that for our little trick. Now, you may have noticed a pattern between these functions by now. If you haven't noticed yet, that's fine. Basically what it is that all the trig functions starting with a co, so that's cosine, cosecant, cotangent, they all have a negative sign in front of them. By combining this pattern of the negative sign, so that's that cosine, some kind of function, turns into or leads to a derivative that is negative, and the fact that we know what the opposite functions are, which is cosine is opposite of sine, cosecant is opposite of secant, and cotangent is opposite of tangent, we can easily memorize the derivatives of trig functions. Let's use secant x and cosecant x as an example of the pattern. Now, secant x lacks the prefix of cosine, which means that its derivative is positive. For cosecant x, since it starts with cosecant, co, that means it'll end up being a negative derivative. Now regarding the derivative itself, for secant x you can see that it's secant x tan x. As for cosecant x, it'll end up being the opposite of secant x tan x, because cosecant x's derivative is the opposite of secant x's derivative. So in order to find the derivative of cosecant x, you swap secant x with cosecant x because they're opposites, and then you swap tangent x with cotangent x because they're opposites, so you end up getting cosecant x is negative cosecant x times cotangent x. Now that you've learned this trick, let's try some problems. So our first problem, we're going to be using the power rule, which is f of x times g prime of x and plus g of x times f prime of x. So that's the power rule, and this is going to be our f of x, this is going to be our g of x. So what will end up happening is we get cotangent x plus 3 times 8 cosecant x, because you use the power rule here and you multiply it with the coefficient, times negative cosecant x cotangent x, because using the chain rule you end up having the x squared function, 4x squared function, and then inside that x squared function you have the cosecant x function. So you end up taking the derivative of cosecant x, which is this, and then you end up adding it, you end up adding this product with 4 cosecant squared x times the derivative of cotangent x plus 3, which turns into negative cosecant squared x. So from here you can see we have cosecant squared x in both sides, or negative cosecant squared x to be exact, so we can pull that out along with 4, so we end up pulling out negative 4 cosecant squared x, and that leaves us with cotangent x plus 3 times 2 cotangent x plus cosecant squared x. Our final answer is going to be the simplified form of this, which is negative 4 cosecant squared x times 2 cotangent squared x plus 6 cotangent x plus cosecant squared x. And that's going to be our derivatives. So our second problem, we're going to be dealing with the quotient rule. So let's define the top as f of x and the bottom as g of x. And the formula is going to be g of x times f prime of x minus f of x times g prime of x. And this is all going to be over the g of x function squared, aka the bottom function. So now that we have the formula, we can start solving. So it's going to be sine 4x times, now the top here we're going to have to use the product rule like we did before, so to find the derivative of it. So we're going to get e to the x times 4 secant squared x plus e to the x tangent 4x, and then the other part will be e to the x tan x times the derivative of the bottom, so the derivative of sine 4x, which is cosine 4x, and like I said, this is going to be all over g of x squared, so that's going to be all over sine 4x squared. So from this, we simplify it, so we can end up taking out e to the x from the whole equation, and we end up getting sine 4x times 4 secant squared x plus tangent 4x minus 4 tangent 4x times cosine 4x. From here, we can simplify the equation further, and this simplifies because tangent 4x is equivalent to 4 sine 4x over cosine 4x, and that's times a cosine 4x. So these cancel out and you're left with 4 sine 4x. So knowing that this turns into 4 sine 4x, we end up getting e to the x times 4 sine 4x secant squared x plus sine 4x tan 4x minus 4 sine 4x, all over sine 4x squared. However, each term here has sine 4x, so we can cancel all those out and turn the bottom sine 4x squared into just sine 4x. Now that this is completely simplified, we end up getting e to the x times 4 secant squared x plus tan 4x minus 4, that's all over sine 4x. So for this problem, we need to find the equation of the tangent line to the function f of x equals cosecant x all over cotangent x plus 2 at pi over 2, 1. So using our knowledge of the quotient rule, we end up getting that this function is equivalent to this, which is cotangent x plus 2 times negative cosecant x cotangent x minus cosecant x times negative cosecant squared x, and this is all over cotangent x plus 2 squared. Now I got this part right here from the derivative of cosecant x, and I got this, the derivative of cotangent x plus 2 using the chart. So from this step, we end up taking out like terms, which in this case is negative cosecant x, and we get this equation as a result from it. Finally, we end up multiplying the terms inside here and adding them together, so we get this end equation, which is equivalent to our derivative. So to find the slope of the tangent line at pi over 2, we plug in pi over 2 into this equation, so that turns into negative 1 times 0 plus 0 minus 1 over 0 plus 2 squared, which equals 1 over 4, so that is 1/4. Now to find the equation, we end up doing y equals mx plus b, so we substitute the value, so y equals mx plus b, we substitute the value, so that's 1 equals 1/4 pi over 2 plus b, which leaves b to be 1 minus pi over 8. So our end equation is y equals 1/4 x plus 1 minus pi over 8.